All right, this is a video showing the making of the key for this worksheet that is a review for our Chapter 3 test. So we'll start right in with problem 1. What is the value of negative 243 to the 3/5 power? The easiest way to do this is probably in your calculator to just type it in. This would be negative 243. So I would put my 243 in parentheses with the negative to show that the negative is part of what I'm raising to the to the 3/5 power. Then the little caret button, which is right above the division symbol, right here. And then the 3/5 needs to go in parentheses as well. So that would be to the 3/5 power. And when I do that, I get negative 27. Okay, so negative 243 to the 3/5 power is negative 27, and that's answer choice A. Okay. Evaluate the expressions. It's very important to understand how to rewrite a root as a fractional exponent and vice versa. So keep in mind, remember we had the base, we have this on your notes somewhere, it shows on your base. This is the fraction. Meaning, for instance, if I have 8 to the 2/3, that means I'm doing the third root. So the bottom number is the root. And the top number says raise that to the second power. So in this case, the third root of 8 means find a number that when I multiply it 3 times, I get 8. And that would be 2. Because 2 times 2 times 2 gives me 8. So this is 2. And then I'm squaring it, so I get 4. Okay, using a fractional exponent is the easiest way to put radicals that have an index other than 2, in other words, other than square root, in your calculator. So for instance, the cube root of 729, in my calculator I can do 729, and you really don't even need parentheses on that, raised to the 1/3 power. That's the exact same thing. So the parentheses around the 729 don't really matter, but you do need them here. This is 729 to the 1/3 power. And remember to turn on your common sense when you turn on your calculator, because we are looking for a number that I multiply 3 times and get 729. In other words, for instance, I saw one today where somebody had divided by 3, and that's not an uncommon mistake. So if you get 200 and something, you need to think, okay, would 200 and something times 200 and something times 200 and something equal 729? And that's a definitely not. But 9 times 9 times 9 does. 9 times 9 is 81, times 9 again gives me 729. So this is 9, either way. Okay, so on part A here, we get 9 for our answer. Part B, this is another one where typing it in the calculator is probably the easiest way to do it. But let's look at it both ways. First of all, it's important to realize that that negative is not in parentheses. So if I have this, that means the only thing to the 4/3 power is 27, not negative. Okay? So it's kind of like saying this. An exponent only applies to the number right in front of it unless you have parentheses. So I could do this in my calculator. I could do 27 to the 4/3 power, and then just make it negative, because that's what you have out front is you have a negative. So it's like saying negative 1 times whatever I get for all of this. If I do that in my calculator, I will get 81, I believe. Let's see. Yep. Okay, here's how I knew it before I did it in my calculator. And that is the other way to write 4/3 power is, and this is a negative, we have the cube root of 27. Remember, the bottom number tells me the root, and we're raising that to the 4th power. The cube root of 27 means find a number that when I multiply it 3 times I get 27, and that I know that that number is going to be 3, because 3 times 3 times 3 makes 27. And then I'm raising 3 to the 4th. 3 to the 4th is 81, and remember there's still a negative out in front, so my answer is negative 81. Because that negative out in front is pretty much after everything else is said and done. All right, next we have, let's make this a little darker. Thought that was going to be darker. the fourth root of 256 cubed. Okay, you could either find the fourth root of 256 first and then cube it, or you can rewrite that as 256 to the 3/4 power. Remember, the root, which is 4, is the bottom number of the fraction. In other words, we're doing this. Okay, and in my calculator it looks like this. So when I do that in my calculator, 256 to the 3 divided by 4 power, I get 64. That's because the fourth root of 256 is 4, and then I raise it to the third power. 4 cubed is 64. So that gives me 64 right here. Now, the fact that this next section says round to 2 decimals, that implies I'm going to be putting something in my calculator and I'm not going to be getting nice integer answers like I did up here. Okay, so part A says you want to find the fifth root of negative 748. Okay, remember that since the negative is up under there, we want to keep it inside parentheses because it's part of what we're finding the fifth root of. And I'm going to change this to the 1/5 power. These mean the same thing. I'm not doing something to it by just changing it to writing it this way. Okay, and then I'm going to do that in my calculator. And the way I do that in my calculator, I do need the parentheses to include the negative here, and then the caret button, and then to the 1/5 power. So negative 748 to the 1/5 power. That would be negative 3.76. Okay, I did say round to 2 decimals, so I want to do 0.76. Next one is negative 128 to the negative 2/5. Again, I need to put that negative inside the parentheses here. Same thing with the exponent. So negative 128 to the negative 2/5 is how that goes in the calculator. So negative 1, excuse me, that was decimal. Negative 128. I put 125, there's 128. Raised to the negative 2 divided by 5 power. And that gives me 0.143, so that rounds to 0.14. Okay. Same thing here. It's telling me I'm likely to get a decimal answer by telling me this, the round to 2 decimal places. Okay, if you have something to the third power, anytime you're trying to get rid of a power, which is what's happening on both of these, you do the root that is the opposite of that power. In other words, the opposite of cubing something is the third root. So I'm going to take x to the third equals 512, and I'm going to take the cube root of both sides. Okay, so on this side I have just x, and on this side I have cube root of 512. Okay, which is the same thing as 512 to the 1/3 power. Okay, so I'm going to do 512 to caret 1 divided by 3 in parentheses, and I get 8. Keep in mind that we could think of it as fractions from the beginning. This is another way of thinking of the exact same problem, really. Another way to get rid of a power is to raise the whole thing to the reciprocal of that power. Notice that what I'm doing here and what I did up here are really the same thing. Taking the cube root and raising it to the 1/3 power are really the same thing. 3 times 1/3 will give me 1. So this is like x to the 1, which is just x. And 5/12 to the 1/3 is the same thing I did right here to get 8. So that means that 8 times 8 times 8 equals 512. So make sure that makes sense and that it works out that way. So x is 8. All right, over here, that means on part B, I'm going to be raising it to the 1/5 power, or taking the fifth root. It's already raised to the fifth. to get rid of a power of 5, I need to do a root of 5. In other words, like this. Or, same idea, raise the whole thing to the 1/5. Okay, either way, we're doing the 5th root or the 1/5 power of 96. So on my calculator, I'm going to do 96 raised to the 1/5 power. And I get 2.491. So that's 2.49. Okay, we also have a power in number 5. So we're going to have to take a root in number 5. But you don't want to take a root until you have that root, that power, alone on one side. Okay, so it starts out like this. This is number 5. First thing I'm going to want to do is subtract 350 from both sides. So I get 3x to the 5th. That's going to be negative 729, I believe, but let me double check that. Yep, negative 729. I still don't have the power alone. I'm going to divide 3 out to get the power alone. Negative 729 divided by 3 gives me negative 243. So x to the 5th equals negative 243. I think this is going to come out as an integer. So I can think of this as doing the 5th root. If you're trying to get rid of a power, you do a root. Or I can think of it instead as the 1/5 power. It's the same thing. Okay, so when I do negative 243 to the 1/5 power, I get negative 3. So that's my answer for number 5. So on number 4B, I haven't written my answer yet. It was 2.49. Number 5 is B. Simplify the expressions. Number 6, I really like A because it's much easier than it looks like it is. Okay, number 6A. It has 27 to the negative 1/3 over 27 to the negative 4/3. I think the first thing I would probably do is get rid of the negatives by putting things on the opposite level. So this is 27 to the 4/3 over 27 to the 1/3. One thing you could do here, if you wanted to, is you could change those to radicals. In other words, the 4/3 power means the cube root of 27 to the 4th power over the cube root of 27 to the 1st power. Cube root of 27 is 3. So I have 3 to the 4th divided by 3. That's 81 divided by 3, or 27. So that's one way to do it. The way I would do it is, remember, when you have the same base and powers, you can subtract those powers when they're on different levels. In other words, I can subtract 4/3 minus 1/3. 4/3 minus 1/3, when we add and subtract fractions, if once we have an alike denominator, we can just subtract or add the top numbers. So this is 3/3, which is 1. 3/3 is 1, so that means this is going to be 27 to the 1, which is just 27. So that's all there is to that one. Part B. I had a surprising number of people asking me about this one. Okay, so let's look at this. You have to figure out how to break up the negative 125. Since I have an odd root here, I would go ahead and keep the negative with whatever I'm doing and take it out. Because remember, an odd root can be negative. Turns out if you try to break up 125, let's do that. 125. Well, things that I know that go into that, 25 definitely does. How many times does it go? 5 times. 25 is 5 times 5. So if I break this down, I can make it negative 5 times negative 5 times negative 5 times x times x times x. Now this is a cube root. Remember that the number outside, the index, tells us how many friends we have to have before we can go out to play. In other words, if I have 3 of something, that comes out. It's kind of like when you're playing cards and you don't put it on the table until you have a group. If you have 3 of a kind or 4 of a kind or something like that. So here I've got 3 3 of a kind, so they come out. I'll lay them on the table. There's nothing left underneath the radical, so that's my answer. So that's the answer for part B. So again, on part A here, the answer was 27. B, we have negative 5x. Okay. C, 6 times the square root of x squared times the square root of x squared. Well, the square root of x squared is pretty quick to simplify. If you are taking the square root and squaring it, those two things cancel each other out, basically. So this is just x, and this is just x. The square root of anything squared is just the thing that was under there. So on top I have 6x squared, because x times x is x squared. On the bottom, 81 times x to the 16th. Okay, let's think about this here. Let's say it was x to the 6th, just because I don't want to write 16 x's. If it's x to the 6th, 1, 2, 3, 4, 5, 6. The index out front, the number out front, tells me how many friends I have to come out and play, in other words. This is a 2. So that means for every pair, 1 comes out. Here's another pair. That's how square root works. Is a pair is a perfect square, so it comes out as 1. Here's another pair. So what I have when it's x to the 6th is I have x to the 3rd. So if you're taking the square root of x to the 6th, basically, however many x's there are, if it's going to come out in pairs, that means I'm going to divide in 2. So if for every pair of x's up here, 1 is going to come out, I'm going to have half as many x's, which is 8. Okay, I'm sorry I wrote 8. It's 81 up front. I can simplify this further, because x to the 2nd over x to the 8th, there's more x's in the denominator. There are 8 down here, 2 up there. That means 2 are going to cancel, and I'm going to be left with 6 in the denominator. Remember that your leftovers are going to end up wherever you had more to begin with. Also, when we have 6 up here and 81 down here, we just simplify those the way we normally do a fraction. I look for something that goes into both 6 and 81, and the thing that goes into both 6 and 81 is 3. It goes 2 times into 6. That's why I said 2. And it goes 27 times into 81. 3 goes into this 2 times and into this 27 times. So this is my final answer. 2 over 27 x to the 6th. Okay? On to the back. Graph the function. State the domain, range, and transformations. All right, I think I'm going to start with the transformations. Oh, we got somebody saying hi. Let's see if I can get that. It's probably too old to get rid of. So we'll just enjoy the hi. It's actually this way. Okay. Y equals negative square root of x plus 5. Okay. The plus 5 is not under the radical. If it's happening outside of whatever's happening to x, then it's not horizontal, it's vertical. So this is saying that you're going up 5. The negative out in front tells me that I've got a reflection. So it's being reflected across the x-axis. So those are the transformations I would say. I would say it's got a vertical shift up 5 and a reflection across the x-axis, and that's all there is. Now remember, this is the transformations from the parent function, which would be y equals the square root of x. So let's look at y equals the square root of x again. You might want to get out that worksheet that you did. You could do a table of values. You should already have one somewhere that we did together. I picked things that are easy to find the square root of, like 0, 1, 4, 9, 16. 0, square root of it is 0, so I'm going to have a point at 0, 0. 1, the square root of that is 1, so I'm going to have a point at 1, 1. 4, the square root of that is 2. So I have a point at 4, 2. 9, the square root of that is 3. So I have a point at 9, 3. 16, the square root of that is 4. So I have a point at 16, 4. So this is what my parent function looks like. Okay, and I am moving it up 5 and reflecting it across the x-axis. Okay, now the question there sometimes becomes, which one am I supposed to do first? Am I supposed to move it up first and then reflect it, or am I supposed to reflect it and then move it up? Well, the easiest way to figure out the answer is, go ahead and just put some points. In other words, I'm going to plug in the same points I already had here into this. So y equals, and let me do it somewhere else because it's going to get moved over there. It's going to get in the way. How about, I'll do it over here. Kind of going backwards. All right, opposite of the square root of x plus 5. So square root of x is 0. I can really do for this whole part, I can look at what I got over here already. So the opposite of whatever I got over here plus 5. So opposite of 0 is 0, plus 5 is 5. So I've got a point at 0, 5. Okay. Then I have, when I plug in 1, square root of 1 is 1. Opposite of that is negative 1. Negative 1 plus 5 is 4. Square root of 4 is 2. Opposite of that is negative 2. Plus 5 is 3. Square root of 9 is 3. Opposite of that is negative 3. And so on. And so forth. Okay, so at 0 for x, I'm up at 5. At 1 for x, I'm at 4. At 3, no, excuse me, at 4, which is here, I'm at 3. At 9 for x, I'm at 2. And at 16 for x, I'm at 1. So here's what my new function actually looks like. It kind of goes through that point a little better than mine. But this one is the one I was asked to graph. So it goes through the points 0, 5, 1, 4, and I'm sorry they're backwards here. This is the x. 4, 3, 9, 2, and 16, 1. Those are those points. Okay. Domain. Well, does it go to the left of this at all? No. So all real numbers that are greater than or equal to 0. That's my domain. X is greater than or equal to 0. And we write that in interval notation like this. The y values, and remember it all has to do with this point. If this point is at 0, 5, I'm going to have a 0 here, and the y values are going to have to do with the 5. Because that's where this point is at 0, 5. So they start at 5 and they go what? Up or down? They go down, so it's to negative infinity. So y is less than or equal to 5. Okay, this is interval notation over here. This is inequality notation. We would prefer this one. It's okay if you have both. I really want you to have the interval notation for sure. Okay? So for your domain, you say from 0 to positive infinity, the range is from 5 to negative infinity. The transformations, we said it had a vertical shift up 5 and a reflection across the x-axis. You'll notice it reflected first and then moved up 5. If it had moved up 5 and then reflected, it would have been way down here. Okay? Domain range transformations, great. We know that it's like this. Oops, I'm sorry, it's right there. And that's what your answer should look like. All right, next one. This one's based on cube root. Remember, cube root goes all the way across. When we do a cube root, the points we like to plug in for the parent function are things that are perfect cubes. And that would be -8, -1, 0, 1, 8 are the easiest ones to do. You could go ahead and do negative 27 and positive 27, but that's going to be a kind of a mess. Sorry about my high over here. It's distracting me. And here's the parent function, y equals cube root of x. The cube root of negative 8 is negative 2. Cube root of negative 1 is negative 1. Cube root of 0 is 0, of 1 is 1, and of 8 is 2. So this is what this looks like. It goes, no matter where I put things, I seem to be putting them in the wrong place for the graph. I'm going to put it up here. This should be fine and out of our way. Here's the parent function, y equals the cube root of x. So now we've got this point, this point, this point, this point, and this point. Okay, there's the parent function. Now, this has two transformations going on. There's a minus 4, and that minus 4 is underneath the radical with x. Things that happen inside the function, so to speak, with x, whatever's happening to x, are horizontal. So that minus 4 is horizontal. Minus is something you would think would mean to the left, but horizontal is always the opposite of what you'd expect. So that actually means right 4. So we are saying that this is a horizontal shift, right 4. Also, we have a 2 out front. The 2 out front is a vertical stretch. Its multiplication is 2 times all of that. So when we have a number out in front, that's a vertical stretch or compression. This is a vertical stretch by 2. Okay? So that basically means in terms of how high off the x-axis each of these things is, or if you can even think of it as low below it, it's going to be twice as far. Same here. It'll be further away. All right, so let's do a few points and see where this is going to end up. When x is negative 8, negative 8 minus 4 is negative 12. If I'm going to do a cube root of negative 12, I'm probably going to grab my calculator. So cube root of negative 12, the same thing as the negative 12 to the 1/3 power. And that gets me negative 2.28, negative 2.3. Okay, and then times 2. I did that later because it's outside the radical. So that's negative 4.57, negative 4.6. So over here at 8, I'm going to come down to negative 4.5-ish. Negative 1 minus 4, that's the cube root of negative 5. Cube root is 1/3 power. So I did negative 5 to the 1/3 power, then I'm multiplying by 2, and I get negative 3.4. 1, 2, 3. Okay. For 0, 0 minus 4 is negative 4 underneath the radical, so it's not going to be 0. So I'm doing negative 4, 1/3 power, then times 2, and I get negative 3.17. Okay, I'm going to just try and get a little bit closer in here. And that's negative 3.2. 1 minus 4 is negative 3 to the 1/3 power times 2 gives me negative 2.88. So somewhere in there. And finally, 2. 2 minus 4 is negative 2. Look at what I've done wrong. I've done something horribly wrong. What did I do that was horribly wrong? I was fine here, okay, and I was fine here, and I think this is why I got confused, because these are the same. Same thing here. What I did on this one, it really only impacted this one, because these were the same, and these were the same. I was looking at the wrong column. I was looking here for my x, because here the x is the same as the y is the same as the x, y is the same as the x, y is the same as the x. Here it's not. I should not do 2 minus 4. I should do 8 minus 4. So 8 minus 4 gives me a positive 4 under the radical, and it's the cube root of 4, and that's 1.58 times 2 gives me 3.17. So at 8, which is right here, it goes up here. Okay, so we've got something along the lines of this. Now where should it turn? It should be turning, remember we said it's 4 to the right, so that means this is 4 to the right. So that's about right. Okay, so this is my new graph. Domain, range, etc. For cube roots, what are the domain and the range? For cube roots, this is cube root, not square root. Cube root, they're both all real numbers. Doesn't matter what you do to them, they're both going to be all real numbers. So we have this, and let's see where else we can go with this. Looks about like this. Not the prettiest graph in the entire world, but I would count it if you put that. Okay, now we have 3 more equations to solve and we're done. Okay, now the difference between these equations and these equations were just to a power, and it wasn't a fractional exponent, it was just raised to a power, x to the 3rd, this to the 5th. So you could take the root. Here, these are roots. So we're going to have to go the opposite direction. We're going to have to raise it to a power. Okay, so we start out, power and root are kind of opposites like division and multiplication. Power goes with multiplication, root goes with division. Okay, so this is like we've divided it up into 5 roots of this thing. So to get rid of it, we need to multiply 5 times, which is a power of 5, not times 5, to the 5th power. Okay, so I have 4x minus 8. Those cancel each other. The 5th root and the 5th power cancel each other out. And that means over here equals 2 to the 5th is 32. So now I have a very simple equation to solve. And I go about doing that. Add 8 to both sides, 4x is 40, divide both sides by 4, x is 10, and that's my answer. Okay? Remember that if you have an odd exponent or root rather, you're going to have one answer, and we only had to get one answer here. X is 10. If there was an even root, we would get multiple answers, or could get multiple answers. All right, on this one, we have the cube root. This is part B of 8. Cube root of 3x plus 9 equals the cube root of x plus 6. All right, to get rid of those cube roots, I can just raise both sides to the 3rd power. So on the left, I have 3x plus 9. On the right, I have x plus 6. And now I collect my x's on one side, and I collect my my numbers or ones on one side. Divide both sides by 2, and I get negative 3/2. And that's my answer. X equals negative 3/2. And last but not least, number 9. Okay, fractional exponent. The best way of thinking of how to get that gone, get rid of that, is probably to raise it to another fraction that's going to make it turn into 1. But I don't need to do that yet because it's not alone on one side. We don't do anything until we have our root or our power alone on one side. So this is x plus 3 raised to the third 3/4 equals 8. So now I'm going to raise that whole thing to the 4/3, because 3/4 times 4/3 is just going to give me 1. So this is x plus 3 to the 1 now. Do I have to write the 1? No, I do not. Which also means I don't really need the parentheses. It's just x plus 3 equals 8 to the 4/3. Now see, here we have a root that is 3. This is good because that means we're only going to have one answer. Remember, the top number is the power, bottom number is the root. So this is saying take the third root or cube root of 8 and then raise it to the 4th power. What's the cube root of 8? 2. So 2 to the 4th, which gives me 16. If you need to do it on your calculator, you can. 8 to the 4/3 power, 4 divided by 3, gives me 16. Okay, so x plus 3 equals 16, subtract 3, and x equals 13. And that is my answer, which is D. Alrighty. If you have not already, I told you to do this at the beginning of the period, but I'm not sure how many of you had done your homework for Friday, which was page 124, 1 through 31 odd. Told you to go ahead and check your answers, but if you hadn't done it already, you couldn't check your answers. So I would suggest, if you have not done any of this, okay, because the equations on here, these few equations, are some of the easier ones. You could have one that's a little harder than these. Try these problems, check the answers in the back of the book. And that's it.